Now, even though we went over this in the last video, I really want to make sure you understand these three parts of the central limit theorem. First of all, again, if your original population distribution is bell-shaped and unimodal, in other words, it's normal, then we can choose samples of any size from that population. So in other words, the sample size does not have to be greater than or equal to 30. It can be any size. And our sampling distribution of means will form a fairly symmetric bell-shaped normal distribution. However, if we don't know the shape of the original population, or we know it's not bell-shaped to begin with, in other words, if the original population were happened to be skewed, or it would be bimodal, or just some crazy weird shape, then we have to make sure that the samples we choose are of size greater than or equal to 30, so that our sampling distribution, those means from each of those samples, form a fairly normal bell-shaped distribution. Now, again, notation-wise, this right here just means mean of all the sample means. Its value, the mean of the sampling distribution, would be approximately the same as the mean from the original population. The standard deviation of sample means, well, its value is going to vary, remember, as the sample size gets larger, then the distribution, the shape, the normal shape of our sampling distribution gets narrower. So, again, the standard deviation of the sample means equals the population standard deviation divided by the square root of the sample size. And we generally call this, right here, this value is the standard error of the mean. So again, if you hear me saying standard error, I'm referring to the standard deviation of our sampling distribution, this right here. So go ahead and read through this if you get the chance. So when you're using the central limit theorem, you have to first of all determine, do you need to use it? And what I mean by that is there's a couple requirements that you're going to have to be able to look at before you can start just go ahead and do calculations. First of all, when we're working with means, we have to determine, is our sampling distribution going to be normal in shape? In other words, we have to look back at the original population, and if it's already normal, then we can use samples of any size. If it's not normal, then we have to make sure our sample size is greater than or equal to 30. If our original population is not normal, in other words, not bell-shaped, if it's bimodal, skewed, just some crazy shape that's not unimodal and symmetric, then we have to make sure our sample size is greater than or equal to 30. If it's not, then we can't do the problem. If we have a skewed distribution for our population and our sample size is only 5, we can't do this. So again, make sure the original population is normal or your sample size is greater than or equal to 30 to proceed. Then the second thing you need to look at is, am I looking for a probability based off an individual value, or is it based off the mean of a sample? Okay? Because that's going to determine, ladies and gentlemen, if you can do the problem at all, or if you can do it, am I going to use a sample standard deviation, or am I going to use the population standard deviation? So as we go through examples, I'll make sure that we look through these things every single time.